Hello everyone, my name is Sandeep Kumar Sharma and I am a pmrf research scholar from IIT Kharagpur. Mm, Today is week 6 of this discussion of traction engineering course, and today we will be discussing. We will first give. I will first give a brief recap of week 1, 2, 3, 4, and 5. Then I will be summarizing lecture 26, 27, 28, and 29, 30. In lecture 26, we have measurement of coal index. In 27, we have pressure sinkage relationship in sandy clay loam soil. In 28, we have measurement of theoretical velocity, actual velocity, and slip for elemental wheel. In 29, we have measurement of contact area of a pneumatic tire on a hard surface. Let's start the discussion of today. Let me first give a brief recap of all the things which we have discussed earlier. The first thing is traction. As we have already discussed, traction is the force by which uh, a tire or a tractor device uses the force from the ground to move ahead. And there are three types of wheel which we have discussed earlier. First is road wheel, one is self-propelled wheel, and one is driving wheel. And fourth one is also there, which is not uh, often used in our discussion. That is brake wheel. The first one is toad wheel. Toad wheel is a wheel in which on which there is no on which there is no torque applied. Only uh, some force is required to move this wheel. Second one is self-propelled wheel on which there is no foot. Means foot is zero here and some torque is applied. Third type of wheel is driving wheel in which there is some pull and there is also some torque applied. These are things we discussed on week one, and then we discussed the tire terminologies on which we discussed that how to calculate the overall diameter of a tire. Uh, the formula of overall diameter was 1.06 into uh, the rim diameter, which is designated on the tire. Yes, Sivaram, do you have calculator with you? Sivaram, am I audible to you?
Yes, sir, you are audible, sir.
Okay, you have calculator with you, right?
Yes, sir.
Okay, last time I told that we will have some numerical questions. I was just giving a brief recap of what we have discussed earlier. So these are things you already know. Where are you right now? Miss, in your room? Okay, I was just telling that how to calculate the overall diameter, in which we include the section height also. 2 into section height and section height is calculated with the section width, which is designated on the tire. Then we discussed the tractive performance parameters, how to calculate the tractive performance parameter, that is rolling resistance or motion resistance ratio, then coefficient traction ratio, then gross traction ratio, then slip tractive efficiency. So today I will be discussing that how to calculate this slip. This how practically the slip is calculated. The slip for slip is 1 minus p of pt. So I will discuss that how to calculate the actual velocity, how to calculate the theoretical velocity practically in lab. Means we have set up a IIT Kharagpur where we uh, calculate the slip of a tire. Then measurement of soil strength, we already discussed how to calculate Kc, K5, and then tractive performance prediction models we have discussed, in which we discussed two types of models. First is residual width and second is basis. In residual width, we had two formulas, one for motion resistance ratio and one for gross traction ratio. That is means. What is motion resistance ratio for given the residual width? Sivarama,
Sir,
what was the motion distance ratio given by which method? It was 1.2. It was 1.2 by wheel numeric plus 0.34. And cross section ratio is 0.75 e to the power minus 0. Minus 7.5 now as seen something like this. And in Vixens, it is a person of mobility and it is also. And mobility is this first thing you have to mobility like we discussed earlier. So today I will be telling that how to if you have a tire, if you have a tractor, suppose this is a tractor, then how will you calculate its actual and theoretical velocity? Do you have any idea? So if this is a tractor given to you, how will you calculate its actual and theoretical velocity?
yeah, proximity sensor you have
Yes,
based set.
yes, sir. Very correct. Do you have this facility in your college?
No, sir.
Uh, no, which tire will give theoretical velocity and which will give actual velocity? Front tire will give actual velocity or theoretical velocity. What do you think? If this is a
French
two-wheel
will,
tractor,
sir.
which velocity?
French will be giving the actual velocity, sir.
It is correct, but why?
Because the rear wheel will be providing the torque, sir,
Yes,
as
sir.
it is powered by the engine and the powertrain. But
Yes,
front wheel, as it is a two-wheel drive, in front wheel it will be just I think as one like without power, it just pushes from behind to the rear wheel, sir. So that
yes, correct.
as there is no torque in it, it will be acting as
Yes, very correct.
yeah, in such a way that there is like
This wheel is powered wheel. Suppose I'm just giving a condition in which this wheel is sleeping 100%. So this front wheel will not move, but this wheel is sleeping. It is moving, just moving, and the vehicle is not moving. So this wheel is just moving. So this is getting all the velocity. The velocity which we calculate here is theoretical velocity, and front wheel is just stored. Means if this will move, the sleep will be considered. So this will give actual velocity. So what we do is that we put a, a proximity sensor here, and we make a plate in which we have some spokes. So number of spokes like which is triggered which triggers this proximity sensor gives generates some pulses on the computer desktop monitor, and from there from the pulses we calculate that what is the theoretical velocity. Suppose that we have on this plate we have suppose 8 spokes, and number of pulse generated is for theoretical suppose anti number of pulse is generated. So first one pulse we exclude, taking that this pulse is just has generated because we have just started the reading. So anti minus 1 is the total number of pulses. Then we divide it by number of spokes, so that for one movement we will get the means pulse. Then we will divide this expression by the time interval, a whole time interval in which we have gathered this information. Suppose delta t. So, and we will multiply it with 2 pi r of this wave. This will give the theoretical velocity. This 2 pi r into this number of this meter per second, this meter generated per second will give what is the distance taken per unit time. This time. So, this question, if you solve it, will become more clear. Suppose that you have to find the sleep value if the number of pulse obtained from 8 spokes at power wheel inside this wheel, we have some splits here, and there are 8 spokes attached here. So we have 8 spokes in the power wheel, and the radius of this wheel is 0.6 millimeter. And this pulse is being generated in number of pulses are 17 at the time difference of 10.6 seconds. And the number of pulse obtained from one spoke, only one spoke is attached here in this plate, calculating the actual velocity. And number of pulse generated is 27 for actual velocity, and time interval 11 seconds. And the rolling resistance of the tire is 4.49. So you have, from here you will get the actual velocity, and from there you will calculate the velocity. You will do 1 minus PA by 50, then you will get the same. So dt you calculate with the same formula, means number of pulse minus 1, number of pulse minus 1 by number of spokes into the time interval into 2 pi r. So for theoretical velocity, take here bit. Are you doing so? This whole procedure is how do we calculate it in lab? Uh, I'm also told in that video in the NPTEL lecture. From there, if you want to see that how these all things are going on in the lab, you can check that there. But the formula is this one.
Okay, that's fine.
So what did you get? Total 17 versus 1 clear minus 1 into number of spokes 8 into 10.6 seconds into 2 5 0.6 seconds.
Zero point 746, sir.
Yes, 0.746. So theoretical velocity is coming 0.746 meters per second. Now actual velocity, you do the same thing. This is actual number of this pulse generated on actual calculating actual velocity means 27 hours. 27 minus 1 by 1 into 11 to 5 and 4.49 centimeter means 0.049 meter.
0.727, sir. 727, sir.
0.727. 727. I have got 0.667. Can you recheck?
Sir.
0.727 it is coming now. Okay, it is
Sir.
0.727. 0.727 meter per second. Now I can put this value in the slip formula. 1 minus 1 minus 0.7375 0.786. What did you get?
0.02546, sir.
0.025, right? So it will be 2.5%. This is 2.5% for this calculation. So last time I told you that we will solve a question in which there will be having too many concepts. So this is the question. There are two tracked vehicles for sale with the same gross weight 135 kg per unit. And the characterization of the soil that is 1.6. Kc and K5 is given, K is given, C is given, I is given. Both the vehicles have the same ground contact area of 7.2 meter square. However, for width, for suppose first vehicle suppose A, width and contact length are different. So B is denoted for vehicle A is 1 meter and length for vehicle A is 3.6 meter. And for vehicle B, width for vehicle B is 0.8 meter and length for vehicle B is 4.3 meter. Estimate the motion distance ratio due to terrain compaction and thus slip characteristics of the two vehicles. Then the calculation will come down contact pressure magnitude. So after doing this estimation of motion distance ratio and thus slip characterization, you have to tell that which tracks will be preferred for our purpose. Both have same area. Can you see this? This 1 into 3.6. 1 into 3.6 is 3.6 meters square. As this weight 135 kilonewton will be found on both the tracks. So 3.6 into 3.6 is 3.6 plus 3.6. That is 7.3 meter square is the total area, contact area of a track. And for one track, the length and width is given, and for another vehicle, the track is 0.8 into 4.5 dimension. With this, if you will do 0.8 into 4.5, you will get 3.6 meters. You have to now select which track will you prefer. Which track will give more.
The one having the larger lens,
That we will verify. This our calculation that why this happens. So the first thing which you have to do is that you have to first find sinkage, then motion resistance, load resistance, which is KZ0 and plus 1 by n plus 1. Then we will Sangeeta, am I audible to you? Hello, Sangeeta. Hello, Sangeeta, are you there? Okay. So start calculating. First calculate sinkage. Do you remember the formula that 3W by something? I'll give you the formula. You can calculate directly from. Do you remember Baker's equation? Sivaram, what is Baker's equation? Sivaram, and what is Baker's equation? Z is equal to, so E is equal to K Z to the power n. Do you remember this formula? From here you can calculate sinkage. This sinkage is equal to E by A. A is Kc and B plus K to the power 1 by n. This you do. Pressure is W and PA. Weight coming, it is 135 kg. What 35 kilometer weight is coming. The total area is 7.2 meters square. So this will become kilometer meter square. This is pressure by Kc is 4.37 divided by B. B is 1 meter here, 0.37 by B plus K5. K5 is 196.72 to the power 1 by n. 1 by n is 1 by 0.67, 1 by 1.6. What syncage are you getting?
I think so, sir. I think answer is 0.228, sir.
Okay, 0.328 meter. RC is equal to rolling resistance for this track is BKZ 0 to the power n plus 1 by n plus 1. Can you again calculate from this equation? Here is this one, Kc by B plus K. B is 1 meter. So I can give you the value. This you have to multiply by 2 as you have two tracks. Means what you have to basically do is 1 into K value what you have obtained from here that I am not reading is 1 into Kc by B plus K5 into Z0 is 0.2 to the power n plus 1 is 2.6 by 2.6 to 2. This you will get as 3.28 kilometers. You can put it sentence for second track. I will give the value of a rolling resistance of the track. Z0. This will remain same. This will remain same. This will change. Length is 0.8 meter here. This will remain as it is. What is the same case coming? Then I will give a value of loading resistance.
Mm. 0.226, sir.
0.226. When you will put this value into leakage at 0 plus answers to the plus 1 gas and this one, you will get the 2.6 kilometer. So Z0 is 0.226 meter and this is kilometer, 2.6 kilometer. From here, one thing is clear, guys. Which wheel is giving less rolling resistance? The second wheel, 2.6 kilometer. And the second wheel's characteristic is that its length is greater than the length of first wheel. The width of first wheel is 1 meter and its width is 0.8 meter. Its width is less, but its length is more. This length is more. So this wheel is giving less rolling resistance. One conclusion is drawn from here. Now we will calculate the overall thrust. We have to calculate estimate the thrust slip characteristics. You know how to do this thrust slip characteristics, how to make this figure, how thrust slip relation. For each slip you have to calculate the thrust. And what is the formula for thrust? Do you remember? Thrust generated maximum. Maximum thrust generated into 1 minus K by I L into 1 minus T to the power minus I L by K. And this maximum thrust generated is AC plus W 10 5. AC plus W 10 5. And this AC is nothing but, this area is nothing but what? P into N. So this is B and C plus W 10 5. And this area is for only one track. We have two tracks, so this will be multiplied by 2. So total thrust generated, maximum thrust generated is 2GIC plus W 10 5 into 1 minus T by IL 1 minus 1 square by 3. So for both the way you have to do this. In that formula, in the calculator, you just write this equation and you just put the value of, just change the value of B and F, change the value of B and L, change the value of, maybe do it for at least for two slip you will do certain things, and you have to change the value of time. So what maximum thrust you are getting? So this will be constant for both of you. This is for both of you, right? This part will be constant, will be same for both of them. It's b into l is 7.2 liters, which we have already seen. So 2 into 1 is 1 into 3.6 into C is given 1 kilopascal. Yes, W10. W is 135 into 10 5, 19.7. You calculate for frequency. Are you calculating? See what?
Yes, sir. Yes, sir.
1 minus K. K is 5 centimeter. Right? 0.05 by slip is 0.05. 5%. For 5% here's the expression. And for first track is 3.6 meter. Then 1 minus 3 power minus 0.05 and 3.65 K. 0.05. So we do for 5%, 10%. What is the total test for frequency and volume? We give a chart. Then we will compare that which track will be more test. And you can say for both of them 55 by 40. Input
I
value,
got that value 54.46, sir.
what value you got for 5%?
The value colored, sir, I got it at 54.56, sir.
This value 54.5.
Yes, sir.
This is with your sleep without situation with length and situation. Okay, this is maximum plus that is correct. 55.54 will be common for both the tracks. 55.54 kilometer. 55.54. Let me multiply with, let me change the value here. Changing. First you do 5% and 10%, then you change 5%, 10%, you have to change like you will get. You do it for 5%, I am doing it for 10%. You do it for 5%. Did you get for any track A or B?
Yeah, I got it as 52.236, sir.
52.83. Okay. For B
One
you
minute,
are
sir.
done.
Let me find for this, sir.
Okay.
For B, I got it as 15.49, sir.
Sorry,
Is it right, sir? For B, I got it as 15.49, sir.
15, not 5.
15 is a 1 5.
15.4.
Is it right, sir?
This is absolutely wrong. Is one you are getting is 52. That is okay, miss, because at least less sleep you are getting more thirst. This can never happen. Miss, 15 will never come. You have done some mistake. 0.05, 0.0.
41.75, sir.
41.
41.751, sir.
41.7. There is some mistake also here because if this will decrease, this side it is increasing, then this side also should increase. You're doing some mistake. Okay, what value you got?
I got as 42.71, sir.
Okay, this for vehicle V, right? There is some mistake in the calculation, I guess, because this should not decrease so much. Okay, one thing can you conclude from here that is that vehicle A, but whatever thrust you are getting, that is, see, in 10% slip you are getting more thrust for vehicle B, but for 5% slip you are getting more thrust for vehicle A. That this cannot be possible. There is a mistake in the calculation process. For vehicle B, it will be higher. Rolling resistance was also calculated for vehicle B. For 10% also I am getting 49.41 for vehicle B and 47 for A. Will you do the calculation again or
So let me try it out.
I just want to get now then. Minus 43.3. Your calculation for 5% for vehicle A is has some error. Do you remember the curve for gross thrust ratio and versus slip? The curve goes like this. Do you remember? As we are
Serious,
increasing,
sir.
as we are increasing the slip, for the gross thrust ratio will increase for sure. So how can you
Sir.
get 50 here? Your calculation for vehicle A is wrong. As you will do 15% slip, you can calculate it. You want to calculate? Here you can get across 50 kilometer if you want to check. For 5% you have some mistakes. And you have to go up to 20% because after that reactive efficiency starts decreasing all of a sudden. Do you remember this curve? Why reactive efficiency after 20% start decreasing? Can you tell
What's that?
why reactive efficiency after 20% start decreasing? We get very high pull after 20%, but that is not economical. That is not good. Why? Because reactive efficiency decreases. And why this happens? I had explained it in last class. What is the reason for power loss in this side? What is the reason for power loss in this side? Remember?
Yes, sir. The power loss in the initial is due to the resistance force produced against the initial force produced against the rolling resistance. The power loss in the at the end, which means after 20% is bit, is due to the energy loss in the during the sleep process.
Yes,
Energy loss in the sense,
this speed is the tire is under ballast or over blast. Can you tell? As you are using the slip, suppose you are getting 100%, let me 100%. The slip you will not get an effective efficiency. What does that mean? That means that your wheel is rotating at only one place. Your action power is not getting converted into power power. That is the conclusion. So what does that mean? That means that your wheel is under ballasted. So you have to give blasting to this wheel, and if you increase blast up so much that all the rolling resistance is converted, all this you're starting pure rolling. You will not get any sleep. So if you don't get any sleep, that is also a problem, and if you get a high sleep, that is also a problem. So as we are here 5%, 10%, we are increasing our thrust. As you will increase up to 50%, 20%. After that, after 30, after 20 only, it will start becoming constant. Suppose here you are getting 50 kilonewton, here you will be 52. Suppose if at 20 you are getting suppose 53, it will become constant. That is the basics we have discussed last class. So we want to do calculation for 15% for the visualization. But the thing which we want to conclude is clear from here. For you have some error in this calculation also, because for vehicle B, the length of the track is higher. That we have seen here. Where distance is coming less. Here also it is coming less, but here in this case you have increased the cost. That should not possible. If you want to read the calculation, you can do this. You will get that max 45 kilometer.
Yes, sir.
So conclusion is that conclusion we will also, but from calculation we have seen that the track measures longer length and shorter width gives more thrust and less rolling resistance. That is the purpose of this problem. So is it clear? Can we move to the next question? Do you have any doubt, Sivarma? Do you want to discuss anything, Sivarma?
So, no, sir.
Okay.
I just want to uh, work with work with the problem, sir.
Sorry, you were having just calculation error.
Yes, sir. Yes, sir.
Your concept is okay. Okay, we will move to the next question.
Yes, sir. Okay, sir.
Here, this question is also a bit challenging. You have given tire, only one testing. I have chosen only one tire. We have to check that whether this tire is suitable for a tractor or not. But all parameters for the tractor is given here. Means the tractor power is 55 HP. Weight of the tractor is 2400 kg. Its wheelbase is 2.1 meter. Weight distribution is 65% on the rear wheel, means 35% on front wheel. Center of gravity 70 centimeter from rear wheel, and an implement is attached to this tractor. Implement is MB block. You have to check that for whether for MB block, this tire is this tire will be suitable or not. That we will do the numerical here. Weight of the implement is 235 kilonewton, 235 kg. Depth is given, weight is given, speed of operation is given, center of resistance and the input is given. So how will you proceed? You have to first calculate draft from XAB draft equation. Means mainly three things we have to do. first thing you have to check is that from the draft calculation, you have to check that what is the weight distribution coming on the front wheel. That distribution should be greater than 20% of the total weight on the tractor. Means then only the tractor will able to generate enough pull. Means that then only the tractor will able to pull this implement. That is the first requirement. Second thing is that you have to calculate overall pull. This pull should match the draft requirement which you will calculate from the SAB draft equation. And the third thing is that you have to go up to from the calculation you have to go up to 20% slip and to do the calculation. Means up to 20% your value should be means your draft coming should be under the ASAB draft equation. So first thing you have is that you calculate the draft equation. From this from draft equation you calculate draft. The draft equation is given here. Fi plus Fi into ABB CV square MW and TD. Do you remember what is this MW and TD? The draft equation is Fi for different soils are given here in the slide. You can take any soil. Suppose if it is not given, you can take clay soil. F1 is for clay soil. You can take one clay soil. A is the ACV draft constants. V is the velocity. Velocity should be in kilometer per hour, meter per second. Do you remember? And this V in ACV draft equation is in kilometer per hour or meter per second. Sivarman, you guess what it should be in kilometer per hour or meter per second?
What, sir?
Yes, it is in kilometer per hour. This is width of the implement and this is the depth of the implement. Width of the implement is in meter and depth is centimeter. So Fi is 1, place 1, A is given, B is given, C is given, velocity is given, this 4.5 kilometer I guess, 4.5 kilometer per hour, and width of the implement is 3 into 20, 2 into 30. This you convert in meter. Means 60 centimeter equal to 0.6 meter. Then depth centimeter is given here, 50 centimeter. From here you calculate draft, what draft you are getting. Divide into 652 is 0 into 3 is 5.9 into 4.5 square. Increase to 0.6 is 50. This will continue open. What value of draft you got? What value of draft you got, Sivarman?
1 minute, sir.
Okay. Did you say any value or you said that you're calculating?
Sir, so what, sir?
Pardon?
I didn't get you, sir.
Okay, okay.
Any value in thousands, sir.
I didn't get you.
6,801, sir.
6,800,
6,801, sir.
6,801. That is okay.
6,801.
6,801 Newton. That is okay.
Yes, sir.
So this Newton you convert it into kg. Means you divide it in 9.8, but you simply divide it by 11. It will come to 680. 680.1. This is the draft requirement. This is the draft from MB flow. This from this draft equation, we have to calculate what is the dynamic weight come from the front wheel, not the static weight. What is the static weight coming on the front wheel? Just 2400 kg into 2400 into 0.35. Because 60 to 65% is on rear wheel, so on front wheel it is 35%. You have to do the calculation and check that the dynamic weight that is coming on the tractor should be greater than 20% of the static should be greater than 20% of the static weight coming here. So what we will do for that calculation, you make a diagram. Suppose this is a tractor. This is the ground reaction from the front wheel, and this is from the side wheel. R1, R2. And the implement is attached here. It is at a distance 100 centimeter. Pull is applied at an angle r theta, that is 15 degrees. This is Py, this is Px, horizontal component of the pull. What is the component of the pull called? So, what is horizontal component of the pull in general term? This is nothing but draft term. So this draft you have obtained from the that is an equation. If you and this draft is nothing but full cost 50 degree. P cost 15 degree is the draft we have obtained 680 kg. So this P cost 15 is 680 kg, 680.1 kg. If you will divide it by cost 15, you will get the full. You do this calculation, I am giving the time 680.1 by cos 15. This is realistic centimeter. This
So not 4.09.
7 not 4.7
091.
not 4.7. And what is Py? Vertical component of the pole. Py is P sine 15 divided by 250. Weight coming is W at a distance 75 centimeter, 70 centimeter. Okay. 183 approximate. What value you got? Plus 183 kg. So first thing which you have to do is that you have to calculate the moment about this R1 axis. This axis. 183. But you are saying something?
182.2. Just now I got that answer, sir.
Okay.
PY, I'm sorry, PY.
183 is 182, right? Get this value, you will say no problem.
I got it 182.21, sir.
183.1. This is our P1. This vertical component P1. We will do some first moment values on R1 along R1. So along R1, you just tell me that what are the moments applied on this line. Means what will be the moment arm of this Py, Px, what what moment it is, what is the magnitude of the moments. This Px is applied at a distance 75 plus this radius. This tile radius is given here is 1.6 meter. So its diameter we have calculated in meters. It comes 1.2 centimeter. And for 616 tile, the diameter is coming as I have the value. Can you calculate it for 616? You do the calculation. If tile designation is 616, what is the overall diameter of what is the radius of this tile? Radius, not diameter. Whatever you will get is diameter, you divide it by 2 and 10. You are calculating radius, right?
Yes, sir. Yes, sir.
अरे यार
65.93 centimeters, sir. 0.65 meters, sir.
0.35. Okay, that is correct.
Yes, yes.
0.35. So suppose this px, this draft is active at a distance, this radius, this px we got is 680 kg. This 680.1 kg is active at a distance of radius, that is 6.35 plus this distance 70 15 centimeter depth of operation means 0.15. This is px into its moment arm. So what will be the direction? What will be the direction for py? If px is, we have taken positive, means this direction log L R1, px is acting in which direction? This is clockwise. If clockwise direction we have taken positive, then what will be the direction of py? Py is being applied at arm of 100 centimeters, and it is in which direction? This direction. This is counterclockwise. So if px is positive, then py will be negative. This minus py into this distance 100 centimeter, py into 1. So you tell me that what will be the moment arm of w. This w is clockwise or counterclockwise for r1. Now r1 w is what in this direction?
Clockwise, sir.
Clockwise. Clockwise we have taken positive. So w into 70 centimeter is plus w into 70 centimeter, that is 0.7 meter. Then r1 is acting in anti-clockwise direction. r2, so if you can take it as per your convenience. If we have taken it at r1, this is r2. So this r2 we will get from there. This counterclockwise is negative for us, that is r2 into 2.1 is the wheel base. r2 into 2.1. This will be equal to 0. All the moments are now balanced. So this will give the value for r2. This r2 you have to check that this should be less than 20% of this value. That is the first requirement. Why we are doing this? I have told this and you didn't ask. Why this should be less than 20% of the static weight from. Because if this will increase by more than 20%, this dynamic weight, then this will give a steering problem. The dynamic weight on the front wheel is responsible for the problem with steering. If it increases very much, then there comes the problem with steering. So do you want to calculate R2? After you calculate R2, you have to calculate it for R1. Then you have to do the calculation for, means you have to check that the draft which you have got from this ASAV equation, you will equate and check that the draft which you calculated is sufficient or not. Means the draft which you will calculate from this method should be less than the draft which you obtained from the ASAV draft equation. That is the second criteria. First criteria is for steering, second is for meeting the draft requirement. With criteria is that you have to calculate the overall pull from the Plexus equation, and you have to go up to 5%, 10%, 15%, 20%. You have to check in all conditions that the draft should meet. So this calculation will become very lengthy. Do you want to do it here or at your home window?
Write myself, sir.
Sorry.
Write myself, sir.
Okay, you do it and tell me that this tire was sufficient for doing this tire was suitable for this implement or not. After you will do this calculation, I will tell that what other requirements are there. If this tire is not meeting the requirement, then you have to increase the width of the implement or other criteria you have to do. Means you have to suppose add ballast. The next week is on ballasting. We are here on week 6, week 7, and week 8 is left. So week 7 is there on ballasting. In week 6 there will only means practical means lab setup was shown in the week 6. Have you watched the videos of NPTA?
No, sir, I didn't complete it, sir. I just watched 1.5 lectures, sir.
Okay, if you will see, then you will find that in week 6 all lab setup which is there in IIT Kharagpur has been shown. How to calculate texture theoretical velocity, how to calculate whole draft practical performance parameters. Everything practical has been shown in this NPTA series. Yes, in this week. In 7th week, there is theoretical class on ballasting, how to what you perform after ballasting, that all things are there. There we can move to some MCQ questions. These are very lengthy questions on very subjective type. In week 7, I will be coming with some CQs. Then you can find if this is really boring, then we can move to some MCQ questions. So this week 7 and week 8 is left. Uh, this calculation you do at your home and you tell me that whether this style is sufficient or not. First thing is that you have to check for steering. Second thing you have to check is for draft is meeting with the draft from HCV or not. And third thing is from this situation you take 5 to 10, 15-20% sleep and you check the draft meeting one. So do you have any question from this class?
Sure.
Do you have any question from query from assignments and PTL assignments?
No, sir.
Why means you were absent that day, right? When Rana was like
What, sir?
you were absent that day when Rana was like on 26th, I guess. He was live for any problems. Okay, you do this calculation. We will meet on next week. Shall we end here? Hello.
Sir, I'm not getting you, sir.
Sorry.
I didn't get you, sir.
You were
Can you
absent
repeat
that
it
day
again,
with
sir?
Professor Rahman was like on 26th.
Can you type in the chat box,
Uh,
sir?
he he arranged a live session for NPTL assignments.
Sir, but I was in the lab, sir. They gave me some work, sir. So I can't. I was unable to attend Monday section, sir.
Okay, no problem. So if you have any query, you come next week with your query.
Yes, sir.
Shall we end here, right?
Yes, sir.
Okay, bye.
Thank you, sir.